Okay. Today, it's our pleasure to have with us Glinskas. I call her Julianna Glinskas. Okay. She's going to be telling us about meteorology work that she's been doing. So I hope that you guys brought your wax-sillion, wire-retardant shirts and umbrellas and stuff with you today, because who knows what might happen in here as you're talking about these things. I want to remind you we'll be having lunch afterwards in the Joyce Room of the Corner Cafe. If you want to join us there for further questions, you do. And otherwise, let's give our speaker a warm welcome.
As you said, my name's Julianna Glinskas. I'm in my final semester here as a chemistry major, so about 80 days left. So I'm here today to talk about the research that I did over this past summer. Okay, works good. Over the past summer, I worked at the National Weather Service in Reno, Nevada, and I did research, and I also launched the Zero-Z balloon. And it's launched at the same time all across the country so that you get a uniform snapshot of what the weather's doing at that time, which in Reno for daylight savings time is about 4 p.m. So this is the view from the office. It's one of the prettiest views that you're ever going to get. It's amazing to me because you can see over 150 miles away. So you'll see a storm build, and it may not even be in Reno's Warren area, but you can see it build up. Just to give you an idea of some of the landmarks that are in this picture, we have the office that is over here, this building. This is actually the Sierra Front. These are the Sierra Nevadas. This down here is downtown Reno. You have the airport, and then this is the Upper Air building. It's kind of on a ledge, and that's where you throw the balloons. And to get a close-up of the Upper Air building, there it is, and you have to run out with it, and you have to let it go before you run out of real estate and go off the edge. So it's a work. You gotta work at it. And there's the balloon that I filled up. It's filled up with hydrogen, so no metal, no smoking, no nothing that would explode. Otherwise, you will explode with it. So to get a little bit into my research here that I did over the summer, I wanted to start off by showing you, this is the area that the National Weather Service in Reno warns for. And it's interesting because out here they define warn areas by county boundaries, but out here they define it by the Sierra Crest. And so everything from the Sierra Crest west is Sacramento's area, but everything east is Reno's area. And they go all the way out to here. And this area east is covered by Elko, and this down here is by Vegas. And so they cover a wide area that's very mountainous, as you can see with the topography. There's a lot of mini mountain ranges here, and that can provide a challenge when you're trying to forecast. So over the summer, there are two main concerns that the Weather Service in Reno is looking for. The first is obviously fire. This is actually a fire that was not too far away from downtown Reno. That's the skyline right there. Fire is so easily started in this area because all the brush is very flammable, and especially when it dries out and it has no moisture, it can catch on fire easily with, even a slight spark. But after a fire, there's still a danger. See, brush and stuff, it has roots that keep the soil together. And when that's gone, there's nothing to really hold the soil in place like there was. So if you get heavy rain, especially in a mountainous area, you run the risk for flash flooding. So that's another huge problem. And they'll watch burn areas for maybe about 5 or so-ish years after there's a major fire, just to make sure that, the soil is able to stabilize again and it's not as much of a threat. So how many here know about what causes a fire, like the fire triangle? You guys have heard the fire triangle? Fuel, oxygen, all that kind of stuff. Well, there's another one. It's the fire behavior triangle. This lets people know how a fire is going to behave once it's started. The three main things you're going to get are the fuels, the topography, and the weather. So looking at what Reno deals with, for fuels, you have flammable fuels such as sagebrush, and they're all dried out by around August, if not sooner, depending on how hot it is or if there's a drought. When it comes to weather, it is very hot. On the other side of the Sierra, it's a rain shadow basically, so you actually run into desert landscape. So not a lot of rain or anything. You get dry thunderstorms where basically it's so dry in the atmosphere that all the rain evaporates by the time it hits the ground. So all you get is the lightning, but you don't get any rain to potentially put out fires. And so that's a problem. And then for topography, you have the Sierra Nevada, the Great Basin, and multiple small mountain ranges. Now, one thing that surprised me personally when I was learning about this is I did not realize how little we know about mountain meteorology. I guess I just kind of assumed we knew a lot more. It turns out mountain meteorology is very complex, and there's a lot of nuance that we haven't figured out in the wind patterns and all that kind of stuff. And just to give an idea of how complicated it is right now with what we know, that's like a graphic of how wind moves through an area of a mountain range. And so it's very complicated. You've got a lot of different things at play. You've got, the synoptic, and then you've got micro stuff down in the valley. You've got stuff on top of the mountain. It's wildly complex, and it's incredible that they even are able to forecast really with the accuracy that they have right now. And that terrain also affects radar coverage. So you see out here, this is radar coverage below 10,000 feet. You want radar coverage to be as low as possible, because if the radar beam is shooting too high into the thunderstorm, you're not going to get the rain or the thunderstorm, or in our case, the tornado, that might potentially be on the ground and actually causing damage. And to give a comparison, the one on the right, this is Shreveport, which is the radar that we use for our area, versus Reno. And you see that there's a huge gap in coverage, particularly in this area. Now, right now, the Weather Service in Reno is looking at possibly trial running where they are going to tilt the radar down a little bit by, I think it's 0.2 or 2 degrees, and it's going to drastically improve the radar coverage, but they haven't gone through all the hoops yet to fully implement that. But most of the time, when radar fails, they have to use the ghost satellites in order to figure out what storms are in the area. And so there's a huge challenge when you have mountains blocking a lot of things. And speaking of the radar, I wanted to bring this up because literally the day after I left Reno and finished my internship, a fire started on the mountain range where the radar is. And what's in red is what burned, and that's pretty much as close as you can get without it actually burning down. They got really close to losing their radar, and that would have been a huge loss for them, but miraculously the firefighters were able to get up there and keep it away from, there's the radar and then there's other emergency equipment up here that does important stuff. So to now get into kind of more of the meat of what I did, let's go over what a red flag warning is. Now, it's important to note that this criteria changes from region to region, so this is not a national thing. But in the Reno area, a red flag warning is if relative humidity is less than 15%, winds are over 30 miles an hour, and those conditions sustain for over 3 hours. And there are multiple sites throughout the warning area that are constantly taking in data of relative humidity, temperature, all that jazz. You need at least 2 of them. Ideally, you want as many as possible just to verify it, but if only 1 hits, it actually doesn't count as a verified warning. And so, you notice I mentioned fire weather zone. So this is the county warning area, and you can see there are little lines here that kind of divide it a little bit. I went ahead, and these are all the numbers. So there are 4 zones in Nevada that Reno looks after and 5 in California. And so it's kind of interesting. These are all drawn in cooperation with emergency managers and fire officials, and so it's a collaborative effort to draw these boundaries. But these are the zones that we're going to end up looking at my research to kind of determine where things are missed, where things were verified, and all that. So when it comes to verification, you need the network that I was talking about, where they have automated surface observation systems, ASOS, remote automated weather stations, RAWs, and then DOT stations. DOT will have periodic stations throughout the network of freeways and all that kind of stuff, and those also help. And in terms of verification, just to give a definition, if a warning is issued and the criteria is met, it's verified. If the warning is issued but criteria is not met for whatever reason, it's unverified. And if criteria comes back as fitting the definition of red flag warning, but a warning was not issued, it is going to be missed. And that's really what I was looking at. And I ended up looking a little bit at the unverified, but only if it was around the miss events. So the National Weather Service as a whole is always looking to improve its false alarm rate. You don't want to get warning fatigue. You don't want to overdo yourself. And so they wanted me to look at the missed events, and they wanted me to see if I could determine any common causes between all of the missed events. And then what would I recommend? See, they were kind of interested because I was an outsider coming in, and they're like, well, what do you think? You're not, you don't normally look at this stuff from an outsider perspective. What would be your recommendations? And so I will go over that at the end. So to give a little idea of the methodology that was involved, so originally I started out with just 2015 to 2017, but there weren't enough data points, and so I ended up expanding it all the way out to 2011, and that was a significant time period for me because it's when the massive drought was hitting the West, and drought is also a huge agitator of wildfires and red flag warnings, all that kind of stuff. Out of those 7 years, we only looked at the months of June, July, and August. Those are the summer months where fire activity really starts to ramp out. Fuels start to dry out. You'll get the sagebrush will die out. Trees will start to, dry out as well. So, admittedly, with this research, there were multiple attempts. This was not like the first time I got it right. So I wanted to kind of show you how I got to where I got. So the first attempt was to look at the red flag warnings in general, these missed events that I found from 2011 to 2017, and determine if there was anything in common. Now, it's important to note that none of these are involved with dry thunderstorms because dry thunderstorms are too much of a variable to really, come up with any solid correlation about forecaster ability or, forecasting model, all that stuff. And so we just looked at events that were straight fire weather events, but they were missed. So I looked at wind data. You can pull up wind anomalies to see if maybe, was the wind stronger that day and they weren't expecting it, or something like that. And that seemed the most promising. I collected it at 3 different levels in the atmosphere. Just for comparison, so 1,000 millibars is the surface about sea level, and then 0 is when you are completely out of the atmosphere altogether. We're at just about 1,000 millibars. Reno's at about 850. So there's a huge gap in how much atmosphere you go up just in that short distance. So I couldn't use the 850 charts that I used for the research when I was with Shreveport. So I had to start at the 700 level, and then 500, and then 250 is where the jet stream is found. And so sometimes we look at that just to see if there's an overall synoptic pattern going on that might be influencing what's going on at the ground level. It started off promising, but then there was a problem. So here are 2 of the events that I was looking at. Blue is minimal anomaly, and red is significant anomaly. And if you'll notice, I'm looking for an anomaly right in this area of Nevada, and there's almost no anomaly. And this kept appearing over and over again, and it was kind of discouraging because it means that it's not a factor. It's not as big of a factor, and that's initially even what my advisor at the Weather Service thought was going to produce maybe a strong correlation, and so we were both kind of surprised. And so from that point, it's like, okay, that didn't work. Let's see what else might work. So the next thing I looked at was air pressure charts to determine if anything like that was going to happen. But the same problem happened. no two missed events were the same. And what you really want in order to say with confidence that, the research is good is you want all the data points to kind of fit in a generalized correlation. And there was none of that. We would have a missed event in far eastern Nevada on the edge of their warning area, and it would be like 3 different possibilities for air pressure, wind anomalies, all that kind of stuff. So in the third attempt, I did kind of a Hail Mary. I just started pulling every chart I could. I looked at soil moisture, drought conditions. I was trying to find literally any correlation I could possibly find with the data that I could pull off of the internet. But then I kind of had an epiphany. I realized that this whole time I've been looking at it from a past research perspective. And the thing about weather forecasting is you're trying to predict the future. It's a lot easier to say there was a rainstorm 2 hours ago than to say, oh, there will be a rainstorm in 2 hours. And so I realized that if I was going to truly figure out why these red flag warnings were missed, I was going to need to somehow figure out how the forecasters were thinking at that time. And that was kind of a challenge because, a lot of these events, you go back to 2011, I don't remember a lot of what I did back then. So, a lot of them, they've issued hundreds of warnings, they're not going to remember everything. But I lucked out because every day, multiple times a day, an area forecast session, an AFD, will be issued. Now, some areas, the AFD isn't that popular, but I found out that in the Reno area, it's actually one of their most popular products. Apparently, people absolutely love to read the AFDs. And so as a result, the forecasters meet that demand by writing really detailed and long AFDs where they pretty much just discuss everything that they're feeling about the weather, about the models and everything. It was beautiful. I couldn't have asked for more perfect data from my perspective because it allowed me to see what the forecaster was actually feeling. So because that was available, I switched up a new methodology. So I decided I was going to start 2 days before the missed events and start reading the AFDs to kind of get an idea leading up to the event. How were they feeling? Did they feel confident this event was going to happen? Were they not sure? Kind of get a feel for that. If there was a verified or unverified event within the 2 days before the missed event, I brought it out further, and that's just because I was trying to look at the big picture as a whole, because one of the things I was starting to wonder was, were things being overlooked because they were so focused on this event that they missed the other event? And so I wanted to kind of bring it out far enough that I wasn't just, doing a huge analysis with too much data, but I wanted to look at the days surrounding the event. And so then I was going to do that and then look for a correlation, see what that would happen. And I did include some dry thunderstorm events, but this was only for the purpose of context. I didn't put in the final data. So going into the results, I kind of went through and in an Excel spreadsheet, I kind of mapped out, I kind of simplified it down to a few main reasons why warnings were being missed. And so I tried to kind of do it where if there were two factors at the same time, I tried to account for that the best that I could to kind of get an accurate analysis about how much is affecting their decision process. So for missed events, here's what I found. So the majority it's missed because there were marginal or borderline conditions forecasted. See, you don't want to increase the false alarm rate too much, and so sometimes if you get an event where it's only forecast to maybe be 20% humidity instead of 15% humidity, you might be a little bit hesitant to issue a warning because, if it verifies, that's great, but if it doesn't, then that counts against you in the statistics of the false alarm rate. There was some forecaster error that was present where a lot of times the forecasters would kind of assume that the models or a certain area of low pressure was going to be in a certain area and they missed it. But another main thing was it was overshadowed by another event. So this ended up being something that was confirmed, a little hunch that I had, where they would miss an event because they were looking a couple days further down the line, and there was a potentially more severe event where they're like, this is the main fire event, this is really going to cause the most problems, I need to put my energy into this. And so in the process, if you got a day, maybe a couple days before that main event, that maybe met conditions a little bit, but wasn't quite as bad, it would just be overlooked. And then you have the overworn concern, which factored in, where basically they were trying their hardest not to overdo it, and so in the process they missed a little bit just because they were trying to be overcautious. And then also forecasting model error. This is where sometimes there was a couple events where the forecasting models, they were literally predicting a center of low pressure like 300 miles apart. One was over here, one was over here. And that completely changes which zones might be affected by red flag warning conditions. That completely changes just the dynamics of what you're going to issue. And so, the problem is if you don't have a lot of confidence and the models can't seem to ever agree, you kind of feel bad about even issuing a warning because, once again, you don't want to do overkill. And so then moving into the unverified event analysis, this was more uniform. So most of the time, if a warning was issued but criteria was not met, it was because of the marginal borderline conditions. There were so many unverified events near the missed events where they would come up to like 25 miles an hour, but because it wasn't 30 miles an hour, it didn't actually verify. And so it was so close, but not quite. So overwarn of previous event, this is if they thought or if the models forecasted a red flag warning event to last longer than it actually did. They would just extend the warnings longer than maybe they should have had. And then this is overwarn due to fire behavior conditions. This is where it wasn't part of a main event, but they issued a warning because maybe there was a fire in the area that was already going and was showing aggressive behavior. Or they knew from a forecaster perspective that the fuels had dried out and it was prime conditions for lighting a fire. Because one of the interesting things is you can have 30% humidity, but if all of your fuels are dried out and the wind is picking up, it will not matter if you have 30% humidity or 5% humidity. A fire will start and a fire will spread. And so sometimes I could tell from the AFDs that the forecasters were trying to account for this, where they're like, there's such a high fire danger that, they almost feel unsure. They don't feel safe leaving it without a warning. And so they issued one, and it ended up being unverified because criteria didn't technically meet, even though fires were being started. So you combine that together, and overwarn related is the biggest, along with the marginal borderline conditions. So to get in a little bit of more of the nitpicky, statistically, the one that missed the most red flag warnings was zone 450, which is right along the Reno area, but it also accounts for 25% of the warnings. And then I did kind of the lowest percentage of red flag warnings is zone 278 in Northern California, and the highest percentage is zone 271. The funny part is you may not remember the graphic that I showed, but 281 and 271 are exactly right next to each other. 271 is right along the Sierra front, and 278 is just a little bit further east. And so it shows you how that even a small difference in topography, even a small difference in distance, it can completely change. And part of that kind of signaled to me that it was more about, the difficulties in forecasting mountain meteorology more than forecaster error or kind of negligence almost. It was more of like, we're trying our best, but there's still a lot of nuances that we haven't figured out about mountain meteorology. In terms of the month, the lowest percentage of verified and the highest missed is August. And then the highest percentage of verified and the lowest missed is June. And when you think about this makes a little bit of sense because June is the start of the fire season when the fuels haven't dried out. Things are a little bit more predictable. whereas August things have dried out. There's a lot higher of a fire concern in general, and so people are kind of on edge trying to figure out. Another interesting thing that I found out in this research, almost all missed red flag warning events are combined to one event. So it's not like they keep missing events throughout the month. It's usually just one event in the month where they have trouble, and then the rest of the month is fine. And that's an interesting thing, because it's not like they're constantly missing events throughout the year. It's usually just that one event that they have trouble with, and then that's where they have the issue of a missed event. So overall, from 2011 to 2017, during these 3 months, Reno had a 63.2% success rate of verified warnings, which, in my personal opinion, I consider a success because of the forecasting challenge. I think, that success rate would be different if you were talking about a flat area like out here where the weather's a bit more predictable. But, when you up the forecasting challenge, 63%, in my opinion, is actually really good. And so I think they're doing pretty good, in my opinion. But so to kind of conclude what I found and what I think about all of this, recapping, most events are missed because they're either overshadowed or the marginal conditions are forecasted. And this is amplified further if the models don't agree. And it's very clear from reading the AFDs that there is a genuine concern from the forecasters of warning fatigue. They want everyone to take the warning seriously. They don't want to keep issuing it to the point where people like crying wolf all the time. They want people to believe, you are in danger, you need to move your resources in the right place in order to prevent fire, destruction, and all that. And so, that was a main contributing factor to why some of the events were missed. And then a little bit of what I was saying, where the events are unverified because of overwarn, but that's mainly because they're trying to compensate for the real conditions that are occurring at the time, which is usually extreme fire behavior. Either a fire is already in progress or it has the potential to spread quickly. So now I want to get to my outsider recommendations that they were curious about. I kind of put this into two categories. One is idealistic. In a perfect world, if we could change everything and science could be perfect, here's what would ideally improve everything. And then I'm going to go over some more of the realistic things that they can implement. So the first one is forecast model improvement. So as technology continues to improve, and as we keep launching satellites that are more detailed, we just launched a better weather satellite recently. As those technological improvements occur, our forecasting abilities are going to get a lot better. But this is kind of one of those things where it's like, it's a little bit of a pie in the sky because, there's a limit to how much a forecast model can ever do. And there's no real substitute for forecasters' knowledge of the area where they can kind of guess, where it's like, I've lived in this area for 20 years. I have a good idea of what's going to happen. But in an ideal world, the forecast models would improve to the point where, they're able to really see everything and you don't get the level of disagreement that they're dealing with right now. The other thing is people taking each red flag warning seriously. This is one of the other idealistic issues with issuing warnings. In an ideal world, you could issue a warning and every time people took it seriously. But because they don't, that's why there's such a push to be conservative about issuing warnings. The third one is people need to stop starting fires. Most of the fires in the West are actually human caused. There are very few fires that are caused by lightning, and usually the ones that are caused by lightning are actually not that severe. They're easy to put out, or they're in areas where they naturally just burn out. The human ones are the ones that cause all the destruction. So ideally, stop starting fires. Listen to Smokey the Bear. He's got good things going. So on to the more realistic things that they can actually do. One of the things I talked to the forecasters about is allowing some flexibility in the criteria, you know, allowing some flexibility where if conditions will actually produce a fire, but they may not actually be like right at that humidity level, maybe like making certain exceptions. The one problem that we were going back and forth is, you know, you don't want to have criteria that's too lax. You need to have a criteria to be met. But, you know, it's one of those ongoing debates. You know, how flexible should we be in our warning criteria? And then what is a good criteria that will get as many red flag warnings verified as possible without, you know, just making everything verified. You don't want to just make it, you don't want to push the boundaries so far out that it's like, oh yay, we make it all the time, but then it's like 50% humidity and it's not really the same. The other thing I talked about with the forecasters is modifying the fire zone boundaries. So you have a huge change in the wind between the upper levels in the mountains and the lower levels. At the upper levels, wind just naturally goes faster than it does at the lower levels. So you have some sites up in the mountains, that will hit red flag warning criteria almost every day. But you can't really use that necessarily because the lower elevations might not be even close. And so there's been talk right now, and nothing's been officially done, but right now they're kind of looking into it, modifying the fire zone boundaries so that you get more uniform topography with the fire zone boundaries, which would help improve the false alarm rate for certain zones. And so that is ultimately going to be a collaboration with fire management and emergency managers. And so these are realistic, but they're slow to implement, and they're very complex. It's not something that can be automatically implemented tomorrow, but it is something to consider. It is something that might potentially increase their verified rate, and so that's kind of pretty much what they can do. So that's pretty much it, but before I go, I wanted to give a quick fire update because I'm from California, and so this matters a lot. This is from the Delta fire up by Redding, north of Redding, and it closed out I-5 for a little bit. And so I wanted to give a quick fire update of what's going on. We have some past fires. Ferguson fire was over by Yosemite, and it killed a couple firefighters. It was contained on August 19th. This is just to give kind of a update if you haven't been paying attention to fire weather and all that stuff. The car fire, that was actually started by a car that broke down. That was contained on the 30th, and I wasn't sure I was going to be able to write this, but yesterday they finally contained the Mendocino complex, which was one of the largest fires in California history. They finally got an upper hand on that. In terms of our current fires, the Delta fire is now 88% contained, so they're pretty good. They're pretty close to this. The Denell fire is about 90% contained. In the last update I read, it's basically in such steep terrain they can't really reach it right now, and so they're pretty much going to wait for the winter rains to come and put it out. And unfortunately, that's the challenge going back to mountain meteorology, mountain fire weather, and all that kind of stuff. Sometimes these fires aren't fully put out until the snow falls, and so that's kind of where they're at right now. So if you like fire weather and you want to learn a little bit more, quick little plug, there's the COMET program. I did these modules over the summer, and they kind of helped me learn a little bit more about fire weather and mountain meteorology. There's a whole range of topics in meteorology in case you want to look it up, but these are the two that really go over fire behavior and fire forecasting. And it's all free. You can just set up an account and all that. So that's just if you would like to learn more. And then a special thanks to my friends at the Weather Service in Reno for taking me in. And so letting me launch all their balloons. And that's pretty much it. So, questions?
Still quite sure about what the mist is. Is that like where there is a danger but they don't say anything about it, or is there not a danger?
So remember I mentioned all the sites that are constantly recording temperature and wind speed and all that?
Yeah.
So they check those daily, and if they see that conditions and criteria was met that would have justified a red flag warning, but no warning was set for that zone, then it's considered missed. Does that make sense?
Even if there was a danger or if there wasn't?
If the data that they get from the portable sites says that the danger was present, humidity was low enough, and winds were high enough, but there was no red flag warning issued, then it's considered a missed event. Make sense?
Is that a bad thing?
It's a bad thing because ideally you want to get every event that is possibly verified. You want to nail every event as much as possible. So, I mean, it's not like the worst thing ever, but, I mean, you ideally would like to catch all of those events. So
I was wondering with that, is there not some kind of automatic labeling from, like if the data can be collected by computers, surely you could automatically send out these events are met and send it to the person instead of expecting them to look through and find it. Is there anything like that? So in other words, the process, does the computer send the data, this should be an event technically, and then the operator has to decide whether or not it really fits in, or how does the computer and the operator play into that?
So when I was talking about how like events, how stations up in the higher elevations will hit it regularly, whereas at the lower elevations, the problem is when you get these zones that have a wide range of sites on all elevations, if you get it where, you know, the mountain sites are constantly sending in, it's meeting criteria, if you just send that through the automated system and it throws out a warning, it may not actually end up verifying because you need multiple sites to verify in order for the whole warning to be verified. And so removing the human component completely is not always the best solution because sometimes you need that forecaster knowledge to sit there and say, wait a second, this data is, you know, inaccurate. You'll also have sites, sometimes there will be a malfunction. I mean, even while I was there was one site that kept saying it was -20 overnight. And the problem is those sites still send in the data. And if that's all being automated, then you're going to get red flag warnings that are there for no reason. And then the Weather Service is going to have to chase those down and individually end up verifying them anyway. And so it's easier for the forecaster to just be the one who's looking over and saying, okay, does this meet criteria? Is there going to be enough sites across this fire weather zone that a warning is justified? So.
Right before you got to the questions part, you showed a sources page. You jumped way too fast.
Oh.
Yeah, I just want everyone to see it again.
All right.
There you go. That's the sources.
Yeah.
So, forgive my ignorance, but you mentioned the margin conditions were a big issue. What did you mean by that? What did you mean by like marginal conditions?
So the hardline conditions that they look for verification is 50% humidity, winds over 30 miles an hour, and it has to sustain for 3 hours. Sometimes marginal conditions can mean anything for it only sustained for 2 hours, or humidity was only at 20%. Or you'll get instances where winds were at 40 miles an hour, and that's good, but humidity didn't verify. And so sometimes you have 3 different things you got to meet, and you have to meet all 3 of those. And so the marginal is usually one of them was met, or they were almost met, or there's a lot of variance in that, but basically it's like it almost could have been verified.
Julianna,
Yes.
for the sake of those that are interested, do the National Weather Service stations offer internships for undergraduates? and how would they find out about it?
I'm not going to lie, I found my first internship at Shreveport because I drove over there and I said, hi, my name's Julianna and I'd like to work for the summer. And I mean, I hate to say it, but there was no official application process, and then people in Shreveport knew the people in Reno, so they're like, oh, hey, we'll call them up and get you situated. So then I jumped over there, and they're all interconnected. And honestly, sometimes you do your best bet by just sticking your neck out there and saying, hi, I'm here, and I'm interested in this stuff. And it's not as fancy as an application or sending in your transcripts, but, sometimes it works. So, yeah.
What does a red flag warning mean for the public? Like, they give a red flag warning, what are you supposed to do about it?
So, red flag warning is basically an alert to the public that says, today is a day where fires could easily start. Please be careful with campfires. Please be careful with anything. They even warn people who are shooting at the local range because, believe it or not, a spark caused by gunfire can actually start a fire. It has happened. And so sometimes you'll notice the ranges, if it's like extremely bad, the ranges will limit the hours or something. And they kind of got to be careful. I will say that red flag warnings have a bigger purpose for emergency managers because it basically tells them this is the area you need to focus your resources on today. Or if there's a fire, it lets them know that this could potentially make the fire worse. But it has an implication for the public in that you need to be careful today with every potential spark you could create. And so it's basically, please don't cause a fire today. Things could get really bad really quickly. So, yeah.
So when a red flag warning is issued, is the public informed of whether or not it is a verified event or an unverified event, or are they just told that it's just a red flag warning? Is there any modifier there?
So they are told, you can search for warnings all across the country. Those are public. The verification analysis is a little bit more internal, and I don't think it's so secretive that if you ask them, they wouldn't tell you, but it's not necessarily going to be the most readily available. So what I did was basically, how I knew that things were missed, that was all stuff that was on their internal computer, but it's not secretive or anything. So, if you really want to know how they're doing in Shreveport, I'm sure you could ask them. So.
All right. Well, if you have more questions for Julianna Glinskas, she'll be here for a few minutes. So again, we'll be at lunch in the choice room. And look forward to seeing you here next week when we talk about forensic chemistry. All right.